Okay, so welcome to lecture once again, guys. Now, in this lecture, I'll be talking about a Langchain, not just a Langchain basic I will be talking about, but I'm going to talk about a Langchain into an application with respect to a Langchain plus RAG plus tools plus agent and providing a memory to my agent. All of these things I'm going to discuss in a detailed way into a practical manner while showing you a code. So let me share my screen, and like I said, so I'm going to talk about basically a Langchain. I'm going to talk about RAG with respect to a Langchain, how we can try to create a tool inside a Langchain, how we can try to give an access of a tool to an agent, and how we can try to provide a memory to an agent. And all together, it will be able to give an answer from a particular data. So obviously with the help of RAG, so it will be able to give an answer for a particular data, a private data you can say. So the data which belongs to me and a data about which LLM is having no idea. And obviously we need a LLM over here. So I'm going to use Euron, as Euron is going to provide me an API access for multiple models. And apart from that, so I need embeddings as well, because whenever I'm going to talk about a RAG application, so obviously I have to store all of my data as a embeddings, then only I will be able to perform a RAG application. So for embeddings, again, I'm going to use a Euron. So where I have an API access for OpenAI embedding models with a length of 1536 with a vector dimension of 1536. And I hope we all understand what is the meaning of a RAG. And obviously we don't know what is the meaning of a tool, what is the meaning of an agent, what is the meaning of a memory, or maybe a Langchain, but at least I'm assuming that we all have an idea about a RAG, because this is what I have discussed a lot in this entire series, in this entire sequence. Now, just to recap this RAG concept in a layman way, so RAG is nothing but, so whenever you are going to ask a question, right, whenever you are going to ask a question, so let's suppose I have my own database, and inside my database there is a information about me is available, right? Information about me is available. Now let's suppose if I'm going to ask a question to my LLMs, so obviously LLM will not be having any kind of a idea. So those data, a private data, is available inside my own database or maybe inside my own file system. So whenever I'm going to fire a query, right, whenever I'm going to fire a query, so it should get a data from my database, right? And then it should append this query. So query plus the data which it is going to retrieve, the data it is going to retrieve, and send this entire information combinedly to a LLMs, right? To a LLMs, and LLMs is going to generate or produce a result for me. So this is where this RAG comes into a picture in a simple manner, right? If you have to understand this RAG in a detail, in a practical manner, so I have already taken a lot of classes on that. So please try to follow that particular part. Then I will be talking about tools over here. I'll be talking about agents in a practical manner. But yeah, so definition wise, if I have to talk about agents, so agents are nothing but an employee, or you can say an intelligent employee, who can try to take their own decision that what to do for what, right? For example, so if I'm going to ask anyone to create a landing page, right? Landing page of a Euron. So obviously my designer will go, they will try to do a research, they will try to do a competitor analysis, they will try to understand the product, they will try to ask a couple of questions. And after that, they will start designing this entire page, right? This entire page. So before that, so obviously they have to do a lot of like a groundwork. So similarly, my agents, right? So it is basically an intelligent employee. It will be able to take a decision on its own that what to do in this situation or what to do in that kind of a situation. And when I'm going to explain you in a practical manner, you will be able to understand it in a much better way. Plus, I'm going to give a memory that whatever conversation or whatever things that we have done in a past, agent will be able to remember, or next time whenever agent will try to give me a response, it will try to consider memory part as well, just like a human being. And here there is a tool. So tool is nothing but a couple of functions, right? Not couple of functions. One function is called as tool, by the way. So a functional access we can try to give to the agents. Because let's suppose if I'm like asking my designer to design a particular page, So obviously my designer needs a lot of things. Maybe to do a research, they need some portal access. Maybe to do a design, they need a Figma access, or maybe a Photoshop access, or maybe to access some of the elements, they need some other platform access. So similarly, this tool is going to work for me. So where one tool will be responsible for doing one particular task, and technically it's a function that we are going to create inside this entire system setup. Okay, so without wasting time, let's quickly jump into this entire implementation, end-to-end implementation, and where I'm going to take my own data, right? I'm going to consider my own data. I'm going to build a RAG application with the help of Langchain. I will be invoking an agents, and agents will be having a memory access, as well as agent will be having a tool access. And then you will be able to see end-to-end application. So whenever I'm going to ask a question, so obviously it will look into my private data, and accordingly it is going to give me the answer. Now, so first of all, just open up your VS Code, right? VS Code. And here, so let's try to open up a folder. Now, inside this folder, Langchain underscore demo is a folder I'm going to create. And inside that, I have to do a couple of things, right? So what things? So first of all, I have to do a project setup. So maybe I can try to create a couple of files over here. The very first file which I'm going to create over here is requirements, requirements requirements.txt. So where I'm going to keep all the things which I'm going to install, requirements. Yeah, that's correct. Then there is, okay, so I think I have created a folder requirements.txt. Okay, so this is the file which I will be using. So where I'm going to keep all the dependencies, then I'm going to write all the logic. So inside a main.py file, and then I'm going to provide a data. So data folder, and inside this data folder, so I'm going to create a file called as founder, founder founder story.txt. So where I'm going to keep my private data. Now private data can exist inside the txt file, inside a PDF file, inside some databases. You just have to read it out. That's it. You just have to read it out. Okay. Now inside this requirement.txt, let's try to keep a requirement that we have. So we are going to keep a Langchain, because this entire RAG application with the agents, we are going to create with the help of Langchain framework. Now, those who are not aware about a Langchain framework, let me give you a little bit of an idea that what Langchain is. So Langchain is basically a platform, or you can say it provides you a library by which you will be able to build, or by using that, you will be able to build any kind of a LLM based, large language model based application. So maybe a chatbot you will be able to build, a memory based chatbot you will be able to build, a single agent you will be able to build, multiple agents you will be able to build, tool you will be able to build, RAG based application you will be able to build. And by doing that, you can solve a problem for a multiple domain. Again, it is going to provide you a beautiful library. And now Langchain is one of the most prominent and beautiful platform which is available out there. Then we are going to use our Facebook AI similarity search. Now here, this will be used to store my vector data. So whatever data which I'm going to keep it over here, I'm going to use a Facebook AI similarity search. You can try to use a ChromaDB, you can try to use a Quadrant, you can try to use a Waviate, you can try to use a Pinecone. I have already discussed all of these databases in my previous lectures as well, right? So please go and refer it if you would like to change your database. But at the end of the day, it's a database where I'm going to store my embeddings, means like a vector of the information I'm going to store it. Then request, TikTok token, Wikipedia. So all of these things I will be using it now. So close it, and then let's do one thing. So let's try to create a fresh new environment. So I'll go into my command prompt, and here, so conda create -n, and I'm going to give a environment name is equal to lang, right? So lang, and then Python, right? Python. So conda create -n Python version wise 3.12 I can try to give, latest one, and keep it all yes. So it will be able to create an environment called as lang for me, and inside this environment I will be doing all the relevant installation, so which I am keeping inside the requirement.txt file. Okay, so this is done. Now I can try to activate this environment. So now environment activation is done. As you can see, lang over here. Let me do CLS, clean the screen. And here, so I can try to do Python install, pip install -r requirements.txt. So whatever I have inside my requirement.txt, it is going to install, right? It is going to install. It will take a couple of like a second of time, maybe not minute of time it should take. Depends upon the system configuration. So yeah, all is done, right? All is done. Maybe I can try to check my installation. So I can try to write pip and then show Langchain. So I just wanted to understand that what is the version of the Langchain which it has installed. So version of Langchain is 3.26. Okay, that's cool. So we are able to do the system setup. All the installation are done and Langchain is available over here. Okay, now close it. Yeah, close it. Now inside this main.py file, I'm going to write all the code in a sequential manner, one by one, I'm going to write a code. So first of all, I have to import all the libraries which I'm going to use it inside this particular class. So here from a Langchain vector store, so I'm trying to import a Facebook AI similarity search library. So this I'm going to use it to store my data into this vector database. Simple. Now, so what kind of a data I'm going to store? So first of all, I have to even create a data for me. So here I have this founder story page. So you will be able to find out founder story page, and here there is a data available about me. So just copy this particular data. This is the raw data I'm going to consider and paste it as it is inside .txt. No need to do any kind of a formatting or anything. It's completely fine. Going forward, even I'm going to show you that how to read a PDF, but as of now, let's try to talk about the TXT. I just need a data. That's it. So data can come from maybe a S3 bucket, maybe from a Azure blob, maybe from my TXT file, PDF file, Excel sheet, or anywhere. That's completely okay to me. So here is my data. Now, so this data, the data which I have taken, so I'm going to convert that data into a vector or into a embeddings, and then I'm going to store it inside a Facebook AI similarity search. Okay. So rest of the things I'll be talking about it one by one. So as I'm going to progress, as I'm going to progress. Now, so you need a couple of things, guys. So like I said in my diagram that you need a LLM, right? And you need a embedding. So you need a embedding models and you need a LLMs, because unless and until you don't have a LLMs, you will not be able to build RAG application. Even your Langchain requires LLM access. So you can try to provide any LLMs which is available out there. That's completely fine. And then you need an embedding so that you will be able to convert your own data into a embedding format. Now, so to do that, I will be using basically Yuri API. So I will be using Yuri API. So here, Yuri API is more than sufficient enough to give me all of these things. So it is having a multiple models. So I can try to use any models for a chat completion. Plus it is giving me embedding models as well. And that too a best one from OpenAI. So this is the model with the vector dimension is equal to 1536, which is a good one, right? It is giving me. So how I will be able to access this? So here we have already given you a code example in a Python as well as in a JavaScript, right? So here, this is the piece of the code I'm going to use for LLM access. So where this is the chat completion URL, means this is the URL where you are hitting the Yuri basically, and you have to provide your API key, by the way, and then you can try to write any kind of a prompt, and accordingly it is going to give you the response. Now, similarly for like a embedding, so we have given you a function over here. You can try to provide any kind of a text, and in return, it is going to give you a vector. It is going to give you the embedding of size 1536. Yeah, 1536. And that too by using a text embedding 3 small model, which is coming from OpenAI itself. So here you have to write these two things, and I have already prepared my function. So no need to like write live, because these functions are basically a static one. So this function, as you can see, so this is a function so which I have created for a embedding. So here you can try to pass your data, your text information, and it is going to return you embedding. Simple. So it will take input as a text data, and then it is going to give you the embedding. Simple. So this is one of the function which I am going to use. Apart from that, so I need a LLM access, which is technically a chat completion, right? So Yuri chat, you can try to provide a message, whatever message you are going to provide to the LLMs. it is going to give you a response. You can adjust your temperature as well as you can try to adjust your maximum number of token in terms of a response. So temperature means, so temperature is going to control basically a randomness of the output. So if temperature is less, output will be more accurate. If temperature is more, it is going to be more random. So it should always vary in between 0 to 1. So you can try to change this one. Maximum token means the token, a number of like a token as an output, it is going to give it to you. So this is going to give you a response for any kind of a messages that you are going to put up. And here I have already applied my API key. So you can try to change this with your own API key. Keep bearer as it is. Just you have to change this particular part, this entire part you have to change with your own API key. Now model wise, you can try to use this model, and apart from that, so there are other 10 models which we have given to you. So you can try to use other model as well. So it's not like you have to use GPT 4.1 Nano itself. So here you have an access of multiple models, right? You have an access of Quen, you have access of a DeepSeek R170 billion parameter, Gemini 2.0 Flash, Gemini 2.5 Pro Preview, and Gemini Flash Preview, Llama series you have an access of, Mistral series you have an access of, OpenAI wise, so GPT 4.1 Nano, Mini, so all these models you will be able to use it. You just have to replace with the model ID. So ID is given with respect to all the models. So just have to change with the model ID, this one, this particular part, this is the model ID, and then it is going to give you a response out of that. So these two things are fine. Right? These two things are fine. And in all my Langchain lectures or maybe a Llama index lecture, I'm going to use the same thing, same kind of a functions everywhere I'm going to use it. So these functions are basically a static function. Now, so whenever we are talking about whenever we are talking about basically this Langchain, so it requires access of your LLM. So obviously this is going to give me a chat completion, means whatever message or whatever prompt which I am going to pass, obviously it is going to give me the response. It is going to give me the response out of that. But for Langchain, so you have to provide this LLMs in a Langchain compatible version. Unless and until it will not be able to get a Langchain compatible version, it is not going to give you a response. So Langchain requires LLMs. Now, so I'm using my own API, right? I'm using a Yuri API, by the way. So which is like not registered with the Langchain. So Langchain is not going to provide you any kind of a direct LLM access or direct functionalities for that or direct classes for that. So to do that, I have created my own custom, right? So I have created my own custom, I would say, a class. So again, this is going to be the static one. No need to understand this part. This is I have created just to make Yuri LLM, right? So just to make Yuri LLM accessible by a Langchain, just to make it compatible. So these are just a boilerplate code, you can say, right? So like here it is trying to invoke a Yuri chat, as you can see. So this Yuri chat has been invoked by this particular class. And here, so I can try to create an object of this class. I can just try to provide, because this is the type or this is the format which will be required by a Langchain, because every framework will be having its own requirement. Yeah, again, if you're going to use a OpenAI, then they are going to provide you a direct OpenAI class, compatible class for that one. But yeah, Yuri is my own custom, like a LLM provider. So for that, I have to make it compatible. So that's the reason. So this is the code. So these are the boilerplate code. You can like keep it and leave it as it is, which I'm going to use it in a future, right? In a future. Now, so now let's start talking about the entire process. Yeah, entire process one by one, one by one. So now let's first try to start with the data. So here is my data, right? Here is my data. So what I will do in a very first place. So let me create a flow over here. So I have my data, right? So I have my data over here. Right? My story data, by the way. So I'm going to read this data. I'm going to do what? So I'm going to read this data. Now, after reading this data, I'm going to store this data into Facebook AI Similarity Search DB. So database, which is nothing but a vector DB for me, So inside this, I'm going to store this data. So this is the process that I have to do. Now, after reading this data, in between, so I have to break down a data into a chunk into a small pieces, because that's my raw data, right? So like all the scrap data I have just put up inside one thing, and then this chunk I'm supposed to provide to my, or this chunk I have to convert it. I have to convert it into basically embeddings with the help of what? So with the help of in between, I would say. So I have to convert it into embeddings, I would say, EMBD, embeddings, with the help of what? So here with the help of URI, right? With the help of URI. So I have to convert this into an embeddings, and finally I will try to store it inside my vector database. Yeah, vector database. So let's do it one by one. Let's try to do this operation. So here, like I said, first of all, I have to read a data. So to read a data, my function is going to be very simple. So with open, inside this data folder, I have a founder story, right? So founder story.txt, I'm trying to open up into a read mode as a English data, by the way, UTF-8 encoding. And then this text is going to return me the entire textual information. So whatever data is available, whatever raw data is available, it is going to return me that part. This text is going to return me that particular part. Now, once it is going to return this data, right? Once it is going to return this data. So like I said that I have to break it down into a chunks, because as of now, it is going to read the whole data, right? It is going to read the whole data. Now, so I have to basically, right? I have to basically break it down into a chunks. Maybe I can try to show you that part. So till this point, I can try to like execute. So here I can write print text. Okay. In a later stage, I'm going to remove it. So here Python main.py file. So no module name, module not found error. So Langchain community. Okay, so let me pip install Langchain community. And let me mention this one. I think I forgot to mention that here into my requirement.txt. Okay, so Langchain community is installed. Let's do a CLS over here, and inside this, let's try to run Python main.py file. So as you can see that it is trying to read the data. It is trying to read the data, whatever data is available. So it is trying to read it out. Fine. So I think we are able to read the data clearly. Yeah. So these are data. Now you can try to keep as much data as possible. So I'm able to read the data. Now remove this print unnecessary. It will try to like increase the output length. Now, so after reading a data, what we have to do? So we have to split this data, right? We have to split this data into a small chunks. Yeah, into a small chunks. So here I can try to do this one. So split a data into a chunks. Now what I'm trying to do, so for I in a range of 0 till a text length with a jump of 500, means 500. So this is what I'm trying to like do it as a chunk, right? This is what I'm trying to do it as a chunk at the end of the day. So 500, then 500, then 500, and then 500. So in this way, I'm trying to create a chunks, and then I'm trying to call this document import, which I have done, right? This document import, which I have done from a Langchain doc store document itself. Now what it will do, so it will try to convert this entire chunk. So it is trying to take this chunk one by one. So chunks in a chunk, because I will be having a multiple chunks, right? And it is going to convert it into a Langchain compatible document format. So I can try to even print documents, as well as I can try to print over here a chunks. So chunks is nothing but just a size of the data with 500. So here CLS, and now so there is a document, as you can see, document, so page content. So this is the entire document which I am able to print, and then here we have a chunk of the data. So here we have a chunk of the data, and in between, so you will be able to find out, or here if I have to show you maybe just a chunk. Yeah. So this is basically a chunk that I have created, and every chunk is having a size is equals to 500, right? 500. And then eventually I'm trying to convert it into a Langchain compatible document format so that I will be able to pass this data to my Langchain. Okay, now once I'm able to do this, means I'm able to create a chunks, and then I'm able to convert it into a Langchain compatible format by using a document. Then what I can do, then I have to, right? I have to convert this entire data as a embeddings, and that embeddings I have to store it inside a Facebook AI similarity search vector DB. With the help of Euron, I will be doing that. Yeah. So with the help of Euron. Now to do that, right? To do that here, so what you have to do, so you have to call basically this piece of the code. So here I'm trying to call Langchain embedding base import embedding. Now, so to make any external embedding things compatible, right? Compatible with the custom embedding one, right? With the custom, because here I'm using a custom embedding query, right? Custom embedding query, and this is nothing but a function which, so Euron chat and Euron embedding. Euron embedding is something which I'm trying to use, which is my own custom one, right? So here I'm trying to use my Euron embedding, which is not compatible by default with a Langchain. So just to make a compatible with this one, I have created Euron embedding class. And inside that, I'm trying to call Euron embedding, because this is again required. This is very much required if you are using Euron in that situation. So here I'm trying to create an object of this Euron embedding class, which is eventually calling a Euron embed, right? Euron embed. And again, so you don't have to change this part of a code at any point of a time. It's going to be same as it is. You can try to change this data, and then you can try to pass any kind of a data. Maybe you are reading a data from some other sources. So in that case, just change this piece of the code. That's it, right? That's it. So Euron embedding class I'm trying to call, and then I'm trying to call a Facebook AI similarity search from text. So this is the function which is available inside the FISS basically. And I'm trying to provide my document, a document which I have already created. Yeah. So which is a Langchain compatible document, which I have already created. And one by one, right? So one by one, I'm trying to pass it over here. And along with this, I'm trying to pass the embedding models. So here it will try to create a Facebook AI similarity search indexes automatically. I believe we all are aware about the indexes, because I have already discussed about the Facebook AI similarity search in my previous lectures. That how Facebook AI similarity search is going to store the data, how it is going to create the indexes. So here I'm just trying to use this library with respect to a Langchain compatibility. So here you can try to use any other vector DB as well. That's completely fine. That's completely okay. So this is something which I have created, which is going to convert my document by using this embedding model. Embedding model is nothing but it's an object of like a Euron embedding class, which is using Euron embedding, right? And it is going to store it inside a Facebook AI similarity search indexes. And then I'm trying to create a retriever object. Retriever object means, so whenever I'm going to pass something, so it is going to retrieve a relevant data. So with the help of this retriever object, I will be able to do that. Okay, so that's cool. So till this point is like a done. Then, so till this part, it's done. I'm able to do it. Then what we are going to do, so we are now going to create a tools. We are now going to create a tools. So till this part, it's done. So tools is nothing but multiple functions I'm going to create. So maybe a function 1, function 2, function 3, function 4. So multiple functions I'm going to create. And then eventually I'm going to expose this entire function as a tool to my like a Langchain, the sequence that we are going to create, right? So here tool is nothing but, many people generally gets confused with respect to the tool, but no, you should not get confused with this things, because these things are nothing but just a simple basic function which I'm talking about. For example, I'll show you one example, right? A simple one. So I'm going to create a calculator, CLCULATUR, calculator underscore tool. This is the function, a plain basic function, which is going to take a query. Yeah, but it's going to take the query. And what it is going to do, so it is going to evaluate the arithmetic. So docstring is pretty much important whenever you are trying to create a tool, otherwise it is going to give you an error sometime. And then here, so we can try to write my like exception handling try and return what? So evaluate, evaluate the query and return it to me as a str in a string. So this is a basic tool which is going to take your plain query and then it is going to evaluate it, and finally it is going to give you this one. So query, I should like make it here like this. Okay, query, and then I can try to write except. So except exception as e, and a return in case of a error. So formatting a string ERROR error, and just try to like return me e, simple, right, with error. Okay, so this is one of the tool, a basic tool. So whenever I'm going to provide the arithmetic expression, so it is going to like invoke this particular tool, and agent is going to decide to call any kind of a tool automatically. Now the next question you are going to ask me over here, that you are trying to like build a RAG, so where you are giving a founder story, and obviously anyone is going to ask a question with respect to this founder story, then why you are writing this calculator kind of a things over here, right? Calculator kind of a things. So maybe, right, maybe I can like I'm chatting with my this Langchain, and in between, if I had to like do some sort of a math, right, I can try to call this one. I'm not going to call this one, by the way. So eventually this agent is going to call this tool automatically. Yeah, this agent is going to call this tool automatically. This is what I mean over here. Okay, so I'll be talking about that more and more. So let me try to create another tool. So I'll try to create a multiple tools over here. So this is again like a summarizer tool. Tool means as of now consider it as a function. So as of now it's a plain function. I'll try to convert it, or I'll try to treat it as a tool going forward. So here summarization tools, so summary, any kind of a text. So whatever text that you are going to like give, it is going to provide it to a Eury chat. So Eury chat, so it is going to provide that as a message, and then it is going to like summarize the entire thing. So whenever like something has to like summarize, it is going to call this summarize tool automatically, or summarize function automatically. Then maybe something we have to search from a Wikipedia, right? So I can try to use this function. Yeah, not I. So when I say I means my agent, right? My agent, my intelligent agent is going to use it. So Wikipedia, that's completely fine. Then there is something called as a translation tool I have created for all of you. Translation means one language to another language. So here again, it is going to like create a prompt automatically, and then it is going to invoke the model, and with the help of this, it is going to translate. So one language to another language, it will be able to translate it. So one is a translation tool, and then another tool I'm going to create called as basically explain code tool. So let's suppose if I had to ask maybe a code explanation, so it is going to invoke this particular tool. Now every tool I have created based on the LLMs, right? Based on the LLMs, I have created all of these particular tools. So you can try to create not just one, two, but you can try to create hundreds of such functions, and you can all together, you can try to give an access of all of these functions to your, right, to your chain or to your agent that you are going to create, because agent needs some sort of agent will be very much intelligent when it will be having access of lot of tools, lot of functionalities, and automatically it is going to invoke, automatically it is going to decide that which one I'm supposed to use at what point of a time. So here a lot of functions I have created. I'm not going to use it now. So this is just a plain function. How it is going to treat, or how it will be converted into a tools, by the way. So here I'm going to create a tool variable, and inside that I'm going to create a tool variable, as you can see, and I have created a list, and this one, this tool function, now this is going to help me out. This is going to help me out to convert a function into a tool, whether I have one, whether I have 100, doesn't matter at all. So here I'm trying to give a name, calculator, then function, and then description, right? Description. Then tool summarizer, I'm trying to call like a function, summarizer function over here, right? Just a function name. So here I'm converting a function as a tool. So list of multiple tools, I'm going to give it to my agents automatically. So it's very easy to convert any function into a tool. So just create a function and then call it over here. So this function again, function again, function again. So just in this way, you will be able to convert everything as a tools. So I'm trying to use this Langchain tools to convert my function into a tools. Very simple, right? Very simple. Now, so once I'm able to create a tools, I have 5 tools in total. 1, 2, 3, 4, 5. So basically one for calculation, one for summarization, one for searching something in a Wikipedia, one for like a translation, one for coding explanation. Yeah, code explanation. So I have a tools over here. Now, so let me come over here. So I am going to provide a tool access. I'm going to provide a tool access to my intelligent agent, to my agent. Along with that, to my agent, I'm going to provide even a memory, right? So I can try to provide this memory to my agent so that whatever discussion that has happened, it will be able to remember it. I'll even show you that what is able to remember. It will be able to remember it. And then whenever you are going to, ask a question which was relevant to my previous conversation, it will be able to understand from the memory, and then it is going to give you the answer. Yeah. So tool, I'm giving access to an agent. Memory, I'm giving access to an agent. As simple as that. So how I'm going to create a memory over here? So here I can try to use basically this part, a conversation buffer memory, right? Conversation buffer memory, which is already available inside a Langchain memory. So this is one of the memory. So conversation buffer memory, I'm going to give an access. How? So I'm just going to create a memory variable, and conversation buffer memory chat history return message is equal to true. So this is how I'm going to create the memory. And all of this, see, as of now, everything is separate. So tool is separate, right? Memory is separate. Everything is separate. When I will create an agent, then I will end up giving an access to it. Yeah, I will end up giving an access to it. Okay. So let's start creating my intelligent agent. So my intelligent agent. So I'm going to give a tool access to an agent. I'm going to give a memory access to an agent. I'm going to give memory access, tool access, LLM access. Yeah. So I'm going to give a LLM access to a agent by the way. So here to create an agent, which is a main part, first of all, I have to give a LLM access. So LLM access, I'm going to give it with the help of Euron LLM class. Yeah. So Euron LLM class I have already created. If you remember, this is my Euron LLM class. This is just a wrapper I have created, guys, by the way, right? This is just a wrapper. So whenever you have to use Euron or Euron like external system, you have to create a wrapper, by the way. So I have created that wrapper. So here LLM, right? Now I'm going to create an agent. So how I'm going to create an agent? So this is how I can try to call the agent. Sorry, my bad. Yeah. So initialize agent is a function. I'm going to give a tool access. Tool means this one, where I have 5 different functions with a different like a use cases. LLM access. So yeah, Euron LLM access I'm going to give to my agent. So to my agent, I'm going to give LLM. So basically it's a Euron LLM access I'm going to give to the agent. Memory access I have to give to the agent. So yeah, memory variable I have created. So I'm going to give that access to the agent, and then tool access I'm going to give the agent. And then here, so I'm trying to create a agent, and this agent is having a type. So there are different type of the agent that you will be able to create. Now, what is the meaning of conversational React description over here, right? So what is the meaning of this particular agent? Let's try to understand that part as well, because that is important, right? So whenever you are trying to create an agent, you should always know and you should always understand that what kind of an agent you should create for what particular purposes. So here, conversational, so I believe we all are able to understand. So conversational means it is going to maintain a memory of your chat. That is something called as conversation, a very first word, right? A very first word. Conversational means it is going to maintain the memory of your chat. React means reactive basically. So it is going to use a reasoning plus acting to plan steps. Means whenever I'm going to perform some sort of task, so how I'm going to break it down into a small one, and then how one by one I'm going to execute it. And the description, so it always try to leverages the tool description to decide which tool I'm supposed to use basically. So here with respect to a tool, I have given the description, right? With the tool, I have given the description over here. So it is going to leverage this description to decide that what tool I should use. So let's suppose I'm doing a summarization, right? So it will be able to understand that, okay, so this tool is going to do a summarization. So let's use this tool automatically. If I'm looking for a calculation, so based on this description, it will be able to understand that, okay, so this tool I'm supposed to call. So this is the meaning of conversational reactive descriptive agent. So this is the agent type I have given. And yeah, so let's move ahead. So this is the agent I will be able to create. Now, once I'm able to create an agent, an intelligent one, which is having a tool access, which is having, like, tool means all the functionality access. So an intelligent person I'm trying to create, which is having all the functionality access, which is having the complete LLM access, which is having a memory access, basically. So what has happened, and which is having like a verbose. Verbose means whatever it will do, it will try to print it. So once this agent is been created, so now I have to, right? Now I have to basically call the entire chain, right? So now what kind of a chain I'm talking about? So I'm talking about a retrieval QA, question and answer kind of a chain. Retrieval means whenever I'm going to ask some question, it should retrieve some sort of information from somewhere. It should use a retriever, basically. It should use LLMs. It should use basically a agent which I have created, and automatically it should decide that one to do what. So here, if I have to create a retrieval QA chain, so I can try to call this one from chain. I can try to provide the LLM access. I can try to provide the retriever access. Retriever is nothing but this one, right? Which can help me out to retrieve information from my vector database. Simple. So retriever access I'm going to provide, and then the return source document is equal to true. So it will return something to you. Okay. So agent is done, and then this chain I'm able to create. This chain I'm able to create. So here, right? So here now we have to run the agent. Yep. Now we have to run the agent. Now, whenever we are going to run the agent, so it should be able to retrieve some sort of information. Agent should be able to retrieve some sort of information, maybe with the help of this one. Yeah, with the help of QA chain. And then eventually it should give you the output. So here is my final piece of the code in a loop. So here, while true, which will be true all the time. So user is going to give the input, right? User is going to give the input. And here I have written the condition that if user input is exit or quit, so break it, break the loop, means don't run it. Otherwise, do one thing. So take an input from the user, so user input, and then pass that input inside the QA chain. QA chain means whenever. Now let's come to the last part. So how it is going to work technically. So here, what I'm trying to say that take a input, right? Once you have an input, now pass this entire input to a QA retriever. Yeah. So it is going to retrieve some sort of information from your vector DB. Yeah, which is nothing but my Facebook AI similarity search. So it is going to retrieve some sort of information from a vector DB, Facebook AI similarity search. Now, once that is done, right? Once that is done, so once it will be able to retrieve the information along with the user input, and then it is going to retrieve the answer. Then what we are supposed to do? So we are supposed to combine the user input and retrieved answer from my for my Facebook AI semantic search. So combine the user input and the retrieve answer, and then pass that inside the agent. Agent is what? Agent is this. So a agent, an intelligent person, which is having a tool access, LLM access, and a memory access, right? So pass this information. So what I'm trying to say over here, that try to combine this one and the output that we are able to get, and pass this to a agent. Now, this agent is having a tool access. This agent is having a memory, right? And this agent is having a LLM access. And now this agent is having a user input as well as extracted data from my vector database, right? From my vector database, it is having an access of extracted data as well. Now this agent, the intelligent one, it is going to decide automatically that, okay, based on the user query, what I'm supposed to do, based on the memory, based on the tools access, based on the LLM access, what I'm supposed to do, which tool I'm supposed to call or like what kind of an answer user is expecting, or if I have to like take some sort of an input from the memory. So this is called as chain, right? So agent will be able to decide all of these things one by one, one by one, one by one, one by one, automatically. So now here, right? So here it is going to give you the final response. So I'm trying to print a final response from a bot. Now in between, so I'm trying to print you even a memory. So chat memory message. So whatever memory it is going to like hold, it is going to store. So just to show you that, okay, fine. So this is the memory. It is like a holding just for the debugging purpose. So when I was doing a coding, so I have done this just for the showcasing purpose, so that you will be able to even see that is okay. This is the memory that it is able to build internally. Okay, that's cool. Now everything looks fine to me. Yeah, everything looks fine to me. So now let's try to test it. Let's try to test it. So here I have to call python main.py file. And if everything is going to work, then it's fine. Otherwise, I'll have to debug it. Maximum retry exceeded. Okay, so caused by name resolution, object failed to resolve, API Euron, HTTP connection pool, host port number. So let me check what is the issue. Okay, so it's a DNS issue, it looks like. Let me run once again. Name calculator tool is not defined. So DNS issue was like it's like based on the URL which I'm trying to hit, which is from a Euron. So calculator tool I have created. Yeah, so I think there is a name mismatch. Calculator tool. So let me like change a name. Calculator tool. Yeah, so now there is no name mismatch. Fine. So now let me rerun CLS python main.py file. Okay, so see, I'm able to run it. Yeah, I'm able to run it. Now here, so I'm going to ask a question that who is Sudhanshu? Yeah, if I'm going to ask a question, so now it will try to prepare an answer for me. So entering a, so here you must be able to see that entering a new agent execution chain. Thought, do I need to use a tool, right? So it is trying to think just like a human being, right? That do I need to use a tool, because is this tool is going to help me out? The answer is no. So agent is deciding automatically that no, I'm not supposed to use any kind of a tool. If I have asked any kind of a question, then go to the document, retrieve it, and then based on that give the answer. So here is the answer, right? And then I'm trying to print a memory into a debug mode. So who is the answer? This is what I have asked, and it has retrieved this information, right? It has retrieved this information, and then finally it is giving me this entire answer. So this is the answer which I'm able to get. So this is something which system has retrieved, and with the help of LLM, so it has made it precise, made it concise, and then ultimately I'm able to get the answer. Now I have to test a memory, whether it is able to memorize something or not, right? So tell me his like a work. Yeah, tell me his work. Now I'm telling his, right? So obviously it should be able to understand that what is the meaning of this his over here. I'm not telling, or I'm not like giving a name, any kind of a name over here, right? So tell me his work, or tell me about his work. So let's see. So whether it will be able to understand it or not. So yeah, it looks like it is able to understand that, right? So it is able to understand, and it is able. Do I need to use a tool? No. And this is the answer. It is able to give it to me. Lanshu work involved in educating and empowering learners to make a complex subject such as big data science and all those things, right? So it is able to understand his. It is able to understand his. This is what I wanted to show you. Means it is able to understand something from the memory. It is able to memorize something, and that is clearly visible even over here, right? That is clearly visible over here, that what it is trying to memorize. Okay. Now, so let me ask that. Tell me what is 3 into 9, right? So 3 into 9 or 3 into 8, let's suppose. Yeah, I have typed 3 into 8. So what is 3 into 8? So obviously when I'm asking 3 into 8, it is able to give me the answer, right? Now, do I need to use a tool? No. So it should have used a calculator kind of a tool, but it is trying to use a LLM, it seems. The result of 3 multiplied by 8 is 24. And now if I'm going to ask that what is 2 plus 3? Let's see whether it is able to invoke my tool or not. So the sum of 2 plus 3 is 5. Let me use some description. Input should be like 2 plus. Okay, so if I'm going to ask a question that do this math calculation, 4 plus 6. Okay, so it has given me an answer. Thought, do I need to use a tool? So still it is thinking that no, it should not use it. It's better to use LLMs, by the way, and see, it is still building the memory, right? Still building the memory. Now, so if I'm going to ask a question that my name is Sudhanshu. Now, translate it in Hindi. Let's see whether it is able to do a tool calling or not. Yeah. So, no, आपका ना AI आपका नाम सुधांशु है. So it is. Okay, so my name is Sudhanshu. So it is able to translate, by the way, right? It is able to translate all the time. So yeah, we are able to do a couple of things over here. We are able to let me call this one. Give me a summary of this entire document. So summary it has given to me. Yeah, summary it has given to me. So this is basically a summary of this entire document, and it is able to build the complete memory. So translation is done. For I in range of 10, print I. Explain me this code. So yeah, it is giving me a very clear explanation that what this code is going to perform, and along with that, so it is going to build a memory as well. So this is the answer. This Python code is a loop that runs 10 times for I in this one. Part create a loop that iterates with I, taking a value from 0 to 9. During each iteration, print I, display the current value of I. When you run this code, it will print the number 0 through 9 each on a new line. Yep. So successfully it is able to give me this entire result. Okay, so that looks cool to me. Now, so as we can see that it is not calling a tool automatically. So every time it is trying to give me no. Now the next question is that why? Just to answer to this question, so you have to make this description more detailed. That's the first answer I can give. The second answer is the LLM which I'm using. So LLM itself is like a sufficient in terms of giving you the answer, whatever answer which I'm looking for, right? So that's the reason. So it is giving me like every time no. Maybe what I can do, so I can try to say that, okay, just try to explain this code by using a tool code explainer that I have given to you. Yeah, so I'm forcing it. I'm basically saying that try to use a code explainer, and then so now you will be able to see that yes, it is trying to use a tool, right? Now it is trying to use a tool because I have forced basically, right? I have basically forced. Now, so in this way, basically I can try to force and I can say that, okay, fine, just like use this one and then try to run this entire operation. So then now it became, do I need to use the tool? Yes, you have to use the tool basically. So observation, certainly the code this, and this, and then eventually it is trying to call my tool over here. As simple as that. Just try to make it more descriptive. This one, try to use some weak LLM over here, or here I'm trying to use basically, where is my agent? So yeah, so I'm trying to use agent type conversational React descriptive. So instead of that, I can try to use a zero sort React description. So if I'm going to use a zero sort means with no example. So here CLS and then Python main.py file, just run it once again. And let's see. So with zero sort, whether it is able to invoke a tool automatically or not without even forcing it. If I'm going to force it, obviously it is going to use it. So do this calculation 4 plus 5. Let's see whether it is able to invoke a tool or not. Okay, so here, if I'll go and check the entire answer, so entering a new agent executor, Langchain core, question was this, thought I need to perform the calculation 4 by 5 to find the answer, action calculator. So yeah, now it is trying to, like, action is calculator. It is able to decide, then input is this, observation is 9, and thought is basically I now know the final answer 9, and it is eventually giving me this one. Yeah, it is giving me this one.